lesson 28, finding the volume of 3D figures. Alright, so this next slide here is going to go over volume formulas. These are crucial. You need to know these in order to solve any of your volume formulas. So I would highly suggest writing these down. If you do not write these down and you don't memorize them, you can't solve these problems. So again, please write these down. For the volume of a prism, that kind of looks like a box, right? A rectangular prism is the same thing as a typical box. We have volume is equal to the area of your base times your height, okay? So that would be length times width times height. So to find the volume here, I'm multiplying all three of these numbers together. The volume of a cube is the side of your cube cubed, right? Cubed. So that's pretty much S times S times S. So if this number here, say it was 5, to find the volume, I would do 5 times 5 times 5. And then the last one, which looks a little bit crazy based off of this example, but I promise you when we do a few of these problems, it'll make more sense. The course gives you this formula here. So 1/2 of your base times the height of your triangle times the base of your rectangle. So I like to think of this as volume is equal to 1/2 base times height. Okay, you don't need to use these subscripts because I think those make it slightly confusing. However, you do need to remember that when you're finding the volume of a triangular prism, you are remembering this 1/2 in front. If you don't remember the 1/2 in front, you will not have the right answer. So again, these three formulas with this you need to write down somewhere. Have somewhere with you. You need to be able to reference it so that way you have it when you're taking the quiz, when you're taking the exam, all that good stuff. So let's start going through some examples. Here we have the volume of this figure. Now notice that all three of these sides are the same. I have 8 centimeters, 8 centimeters, and 8 centimeters, which means that this is a cube. So the first thing I always do when I am solving these problems is I always start with my formula. Which here my formula is not right. Here I should have S cubed. Or volume is equal to S times S times S. S, or my side length, is 8 centimeters, so I would have 8 times 8 times 8. Now with these volume problems, you can type them into a calculator to get your answer. So here when I do 8 times 8 times 8, my volume would be 512 centimeters cubed. Now in the course, I believe it just asks you to type in 512. You don't need to type in centimeters cubed. Here's our next one. We're finding the volume of the following figure. Okay, now again, start with your volume formula, that 1/2 base times height times height. Now on problems like this, they will often give you this number on the side here. This is called slant height. You do not use those numbers. Okay, if it is on a diagonal, you are not using it. This is an extra number that they give you to throw you off. Okay, so don't be fooled. So I have 1/2. My base is 3. My height is 4. And my other height is 6. So that is it. All you need to do is type that into your calculator. Again, knowing the formula will make these problems 30,000 times easier. So if you don't know the formula, you cannot solve these. I promise you, you can't guess. I don't know why I'm putting that in parentheses. I'm just going to put the rest of these like this. So when I type it into my calculator, I get 36, and this would be centimeters cubed. But again, you can just type in the 36 into the course, and we'll all be good. Please don't forget the 1/2 in front when you have a triangular prism. Okay, that's key. Here I have a box. Okay, I want to find the volume of the figure in inches. Okay, notice how I am given feet for 2 of my different sides, which means I need to convert those to inches before I start plugging in numbers. Please pay attention to your units. The course loves to give you units that are not the same. Okay, I know it's mean because they're tricking you, but be smarter than the course and look and pay attention to your units. So if I have half of a foot, that is the same as 6 inches. And if I have 1.5 of a foot, 1 foot is 12 inches plus half, which is 6. So 12 plus 6 would give me 18 inches. So now I can use my BH. Remember that B is the area of your base. Okay, area of any rectangle is just base times height. So I would do 6 times 18 times 4. I'm just multiplying all three of these numbers that I have together. So 6 times 18 times 4 gives me 432 inches cubed. The reason why our inches are cubed, or all of our units here are cubed, is because we're finding volume. Okay, with volume, you will always be multiplying three numbers together from your problem. Notice how in this first option, I am multiplying 8, 8, 8, three numbers together. Here, I am multiplying 1/2, 4, and 6. This 1/2 doesn't count as a number because that's a part of our formula. But in all of these volume problems, I am multiplying three numbers together from my figure. Okay, so keep that in mind. Now, aside from finding volume, you can also find volume of composite figures. Now, composite figures are two figures that are mushed together to make them one. So there's a few different ways you can go about this, and I would recommend either like taking a picture of this and putting it in paint so you can kind of separate it, or you can try and draw it really quick and separate it. So I see two boxes here. I see this flat bottom box, and then I see this other box that's kind of on its side. So I'm going to break these figures apart by drawing a line right here. That makes my flat box one, and then that makes the box on top a separate one. Okay, so what I'm going to do first is find the volume of this bottom box here. Okay, I'm going to outline it in red, so that way I know that this first figure is I'm finding the volume of the bottom. Now on the bottom, I know all three numbers I'm multiplying together, right? 14, 20, and 2. Now on the second box on the top, right, here's my second box. I know that I'm going to multiply 4 and 8, but I need to know this number down here. If I look, this bottom side is the same exact length as this bottom side here, and this bottom side is 20 centimeters. So that means this bottom side is also 20 centimeters. So there we have those three numbers that I'm going to multiply together. So 4 times 8 times 20. Now with composite figures, once you find the volume of both, all you need to do is add them together to get the total volume. So I'm going to bring back our calculator, do the first one in red, so 14 times 20 times 2, and then 4 times 8 times 20. So I would have 560 plus 640, which gives me a total of 1200. So the volume of this figure would be 1200. So I had 560 plus 640, which gave me a total volume of 1200 centimeters cubed. So I think the most challenging part of these questions would be figuring out how to cut your diagram. Okay, use the numbers that you have to kind of help guide you. Okay, like here I knew that this side over here was 8 centimeters tall, so I want this side over here to also be 8 centimeters, so that was why I cut it right there where I did, because I knew that side height. Okay, so just the more you work with these, the more examples you do, the more comfortable you'll feel. Alright, Raylan needs to find the volume of the following figure formed by the triangular prism stacked on top of a rectangular prism. So here, this is kind of nice because they give you the cut, right? Here's my cut right there in the center. So I have this triangular prism on top and then this box on the bottom. Now I know that the box is 6, 7, and 10, right? I know that the height of my triangular prism is 5. However, if this bottom side here is 7, that means this bottom side is also 7. Let me get a color that I can actually write on here. So this is also 7 meters, and this is also 10 meters. Now, here is where knowing the formulas is crucial. It says that she multiplies 6 times 7 times 10 to get the volume of the rectangular prism. That's good, right? You just multiply all three of those together. Then it says she multiplies 5 times 7 times 10 to get the volume of the triangular prism on top. What is she forgetting on that triangular prism? Hopefully you know. Think back to our formula of finding a triangular prism. She's forgetting this 1/2 right here. So she did not find the formula correctly because she did not find the volume of the triangular prism right. Okay, the rectangular prism was fine, but since she forgot to multiply 5 times 7 times 10 by 1/2, she did not find the volume of the triangular prism correctly. So again, knowing your formulas is so important. Please write them down somewhere or have them somewhere where you can go back and reference. Alrighty, here we have a problem that just says the base of a triangular prism is a right triangle, and it is a 20 feet base and height of 120 inches, and the height of the prism is 5 feet. We want to know what is the volume of the prism in feet. Again, a question where they give you inches for one of them and you need to convert it to feet first. If you take 120 inches, divide it by 12, you will get 10 feet. Okay. Now, in this problem, they don't give you a picture, but I always recommend having a picture. Okay, this is what that prism would look like, and then labeling it to kind of help you. So if the base of the triangle is 20 feet, okay, the height of the triangle is 10 feet, and then the height of the prism is 5 feet. All right, so I labeled my diagram. Always start with your formula. The more times that you write this formula down, the more times you'll remember it, the better you will do on your exam and quiz. So my volume is equal to 1/2. I'm going to multiply those three numbers together. And let's bring back our calculator to help us with that multiplication. Make it go by a bit faster. 1/2 times 10 times 20 times 5. Tells me that my volume here is going to be 500 feet cubed. So 500 feet cubed. All right, let's see. It says that Jake has a shipping box with the following dimensions. The length is 12 inches, the width is 4 inches, and the height is 8 inches. Havana has a similar box with dimensions that are half of the length of Jake's box. We want to know how many times larger is the volume of Jake's box than Havana's box. For this problem here, we need to first figure out the dimensions of Jake's box and then figure out the volume of Havana's box. So here I have length of 12, height of 8, and width of 4. Now for Havana, her box is half of the dimensions and lengths of Jake's. So instead of this height here being 4, half of 4 would give me 2. Half of 12 would give me 6, and half of 8 would give me 4. Now from here, I can go in and find my volume formula, right? Multiply all three of my numbers together. Again, remember, whenever you're solving for volume, you are multiplying three numbers from your problem. And then let's grab our calculator to help us again with this multiplication. So Jake's box would be 4 times 12 times 8. Havana's box would be 2 times 6 times 4. Alrighty, let's see. So Jake's box would have 240. And then Havana's box was 48. Now, I want to know how many times larger Jake's box is, the volume, compared to Havana's box. Now, to figure that out, there's a few things you could do. You could do a bit of guess and checking, right? Saying, well, what number times 48 would give me 240? If I multiply this by some number, right, what would that be to give me 240? Or you could go the opposite way and just divide. So if I were to take 240 and divide it by 8, nope, not 8, 48, I would get that Jake's box is 5 times larger than Havana's box. Alrighty. So that is all I have for this lesson. If you have other questions or would like some help, please let me know. The quiz code for this quiz is TOAST, all lowercase. Okay, TOAST, all lowercase. If you have other questions, again, please let me know. Other than that, have a wonderful day.